Hi, welcome to Kagaku Library.
Hi, I'm Akari Kazuna.
Today, we are going to learn about an atomic weight.
Yes? Is it the weight of an atom?
Kind of, but it's slightly different.
What do you mean?
I think the history of atomic weight tells you the differences. So, let's get started. Today, we are going to start from the review of chemical substances. Do you remember the basic of chemistry?
Is it the aggregate of atoms?
Great! The basic of chemistry is, every matter is made up of the aggregate of atoms.
I see.
Now, to get to the point, do you know the word of mass?
Sure, that is the weight of matter.
Right in a way, but strictly, there are some differences between mass and weight. However, you can think, these are almost the same for now.
Ah, okay.
Then, I think you can image that every substance has mass.
Yes, I know that.
Okay, now, this will be the important point today. Could you think that every atoms also should have mass?
Well, kind of. I think it might be.
Okay, since older scientists also thought that, they struggled to measure the mass of one atom. This is the story about 200 years ago.
But is the atom very small?
Yes. It's very small, you cannot be seen. Obviously, scientists failed in the measuring.
It's like that. It seems like reckless.
But scientists thought hard to solve this problem.
They could solve that?
Yes, in the end.
Is that serious?
Well, next, I'll tell about that thought of scientists.
科学ライブラリー。
Now, I'm going to tell you how scientists found out the mass of one atom.
How did they do?
In a word, they used the mass ratio during the chemical reaction.
Mass ratio?
That's it. For instance, from the chemical reaction of carbon and oxygen, we can guess the mass of one atom. Do you know the chemical formulas of solid carbon and oxygen gas?
Of course. C and O2.
Right. When both of them undergo a chemical reaction, what kind of do you think a chemical substance will be generated?
Let me see. C and O2. So, is it carbon dioxide?
That's right. It's generated carbon dioxide, like this.
I see.
Then, through the chemical reaction, it is known that 3 grams of solid carbon is spent against 8 grams of oxygen gas. By 200 years ago, scientists had understood this. You also okay?
Ah yes. Okay.
So, do you find out the mass ratio of carbon and oxygen as 3 grams to 4 grams?
What? Why is it like this? 3 grams to 4 grams. I don't know what this is saying.
Okay, let's just think calmly about 3 grams to 4 grams. This is because this chemical reaction is C plus O2. I mean, this is like 3 grams of 1 C atom is spent against 8 grams of 2 O atoms. So, the mass ratio of carbon and oxygen is 3 grams to 4 grams.
That makes sense.
Like this, scientists thought the mass of one atom. And next, let's think the mass about other atoms.
科学ライブラリー。
This is the mass of one atom that scientists investigated in various kind of atoms.
It looks like difficult.
Yes. This is because older scientists thought 100 of one oxygen atom is the standard of the mass.
Why did they do that so?
I don't know.
Excuse me?
Actually, this seems to have no reason. I think 100 is a good round number.
That's without thinking.
Exactly. So, the most of the values indicated decimals.
It does.
Then, they changed the values not to become decimals. The result is this.
It became simpler. The value of oxygen is 16?
Yes. When the value of oxygen decided on 16, almost all values became whole numbers.
Is 16 like specific?
You have a point. But this 16 of oxygen certainly has meaning.
Is that so?
Yes, this will do next part today. Anyway, these values are called atomic weight.
I see.
So we can say, the atomic weight of oxygen is 16, carbon is 12, hydrogen is 1, and so on.
I think so.
Did you? Then, are you okay? The mass of one atom was guessed from the mass ratio during the chemical reaction and called an atomic weight.
Yes, it's okay.
Then next, let's think about the relationship between an atomic weight and a mass number.
せーの。 リー。
Do you remember a mass number?
Actually no.
Well, a mass number is the total number of protons and neutrons in an atom.
I did learn that before.
You know? Then do you know the mass number is relative to the atomic weight?
Is it true? I didn't know about that.
Right. But this relationship is simple. The atomic weight of the element is almost the same with the mass number of that atom.
Really? What's that mean?
Yes. For instance, the atomic weight of oxygen is 16, you know?
Yes, I know.
Then, most of oxygen atoms have the mass number 16 too.
Oh, it's the same.
Right? Also about carbon, the atomic weight is 12, and most of atoms also have the mass number 12. Why do you think both of these are almost the same?
Sorry, I have no idea.
No problem. That is because an atomic weight and a mass number both mean the mass of one atom.
Is that so?
Sure. It's like, one proton or one neutron means one atomic weight. Most of carbon atoms have 6 protons and 6 neutrons in them. So both of the mass number and the atomic weight of carbon are 12. Also about oxygen, since most of the atoms have 8 protons and 8 neutrons. Both of the mass number and the atomic weight are 16.
Well, I kind of get it.
I think you can think simply, one carbon atom is 12 grams, and one oxygen atom is 16 grams. These are the mass of one atom in a sense.
I think that's not so confusing. It looks easy to remember.
I'm glad to hear that. I think I've talked too long, so let's finish up today.
Well, okay.
I hope you got curious and understood about an atomic weight. Then, thank you for watching this video.
Hope to see you next time.
See you next time.